Without a critical supply of oxygen gas dissolved in water, fish and other aquatic organisms would drown. The amount of dissolved oxygen in water is one of the most important indicators of water quality and environmental health.
Dissolved oxygen is the amount of gaseous oxygen, O2, dissolved in a body of water. The most common units for measuring DO levels are milligrams of oxygen per liter of water, mgl, or parts per million, ppm O2, where 1 ppm equals 1 milligram per liter. We have created a system in which we are able to test the amount of dissolved oxygen in the local lake, Oakford Lake.
Materials we used in the testing of dissolved oxygen in Oakford Lake includes sodium thiosulfate, soluble starch, sulfuric acid, Winkler solution number 1, Winkler solution number 2, Pasteur pipette, syringe, water, which was distilled, graduate cylinder, Erlenmeyer flask, and rubber stopper, hot plates, hot water, ice, thermometer, test tube rack, test tube, and wash bottle.
In order to find the amount of dissolved oxygen in Oakford Lake, we had to follow a procedure of approximately 10 steps. Step 1. We took 2 different samples, both lake water and distilled water, and put them into separate flasks. We shook the flask containing distilled water to mimic dissolved oxygen in the water. Step 2. The 2 samples were then poured into separate test tubes. They were then immediately closed with a stopper. Step 3. We added 6 drops of Winkler solution number 1 to the samples, as well as Winkler solution number 2. We put a stopper on the test tubes and inverted them to mix their contents. When this happened, a brown precipitate formed. The precipitate eventually settled to the bottom. Step 4. 6 to 7 drops of the concentrated sulfuric acid were added, and the stoppers were replaced on the test tubes. Both samples were inverted to mix. The brown precipitate dissolved and turned into a clear amber solution. Step 5. We then poured 20 milliliters of the treated water from the test tube into a flask.
Step 10. 10 milliliters of sodium thiosulfate solution was filled in a syringe and the initial volume was measured. Then we added the solution to the 2 samples of treated water until it faded to a pale straw color. Step 7. 6 drops of starch solution was added into each flask and mixed. The solution was then turned dark blue. Step 8. We continued to add the sodium thiosulfate solution until the blue color faded completely. The final volume of sodium thiosulfate was recorded in the syringe. Step 9. To calculate the volume of sodium thiosulfate added, subtract the initial volume from the final volume, which was 7.6 milliliters for the lake water and 7.5 milliliters for the distilled water. The volume of the sodium thiosulfate added would be the same for the dissolved oxygen levels, 7.6 parts per million and 7.5 parts per million.
After conducting the procedure, we collected our data in a chart and graph. As you can see, the amount of dissolved oxygen was approximately 7.6 parts per million opposed to the distilled water, which measured 7.5 parts per million.
When compared to other amounts of dissolved oxygen, Oakford Lake had a relatively healthy amount of dissolved oxygen in its water. This makes it more likely to hold healthy aquatic life.
When there is a small amount of dissolved oxygen in the waterways, disastrous results can range from large fish kills to little to no life at all. This shows the environment the animals are attempting to live in is extremely unhealthy.
Oakford Lake is an ideal waterway for aquatic life to live in when viewing dissolved oxygen levels. According to our data, our fish are thriving in their environment.